Yesterday, DNS answered the question, where should we go? But imagine someone hands you an address without a map, without roads, without directions. Would you arrive? Probably not. The internet faces the same problem. Knowing the destination is only half the journey. Now, another question appears. Which road should the data take? Because unlike people, the internet doesn't have one road, it has millions. And every second, someone must choose.
If we could see the internet, it wouldn't look like websites. It wouldn't look like applications. It wouldn't even look like clouds. It would look like the largest transportation network ever built. Countless digital highways, crossing cities, crossing mountains, crossing oceans, connecting billions of devices into one living system. Every second, new travelers arrive. Some carry emails, some carry videos, some carry financial transactions, some carry conversations with artificial intelligence. Each one has a destination. Each one needs a route. Each one expects to arrive almost instantly. The remarkable part is that traffic never truly stops. It simply keeps flowing.
Imagine driving a country. Every intersection presents a choice. Turn left, go straight, take the highway, avoid traffic. The internet makes those same decisions, except it makes them millions of times every second. Those decisions belong to routers. Not the small routers sitting inside your home, but enormous routing systems connecting internet providers, data centers, and entire countries together. Every router receives one question: where should this packet go next? Not eventually, now. The answer must be immediate, because another billion packets are already waiting behind it. Here's something unexpected. The internet doesn't always choose the shortest route. Sometimes the fastest path is actually longer. Why? Because speed isn't determined by distance alone. Traffic matters, capacity matters, reliability matters, availability matters. The best road isn't always the closest one. It's the one most likely to deliver your data without interruption. And deciding that is far more complicated than simply reading a map.
Imagine every road on Earth sharing the same traffic system. No traffic lights, no police officers, no central control room. Yet somehow, billions of vehicles continue moving without complete chaos. That is remarkably close to how the internet operates. No single organization controls every route. No master computer calculates every journey. Instead, each router understands only the roads connected to it. It observes, it evaluates, it decides. Then the next router does exactly the same thing. One decision after another, until your data finally arrives. The internet isn't guided by one giant decision. It's guided by millions of small decisions working together. Road conditions change. Fiber cables break. Hardware fails. Power disappears. Traffic suddenly increases. The internet expects all of these things. Every router continuously asks, has anything changed? Is there a better route? Is this connection still available? Should traffic move somewhere else? The answers never stop changing, which means the internet never stops adopting. Unlike a printed map, its understanding of the world is always being updated. Every second, the network learns something new, then quietly adjusts itself before most people notice anything happened.
Now imagine an entire road suddenly disappears. Not tomorrow, right now. A cable is damaged. A connection fails. A network becomes unavailable. Does the internet stop? Usually, no. Because long before failure happens, alternative routes already exist. Routers immediately begin sending traffic elsewhere. Not perfectly. Sometimes users notice slower performance. Sometimes delays increase for a few moments. But the journey continues. The internet wasn't designed to avoid failure. It was designed to survive failure. And that single philosophy is one of the greatest reasons the modern internet remains so resilient.
Here's another surprise. Your data doesn't always travel together. A large photo, a movie, a document, even this video is divided into countless smaller pieces, known as packets. Each packet can take a different route. Some travel north, some travel south. Some arrive first, others arrive later. Only when every packet reaches its destination are they assembled again into the information you actually see. The internet doesn't move files. It moves millions of tiny pieces that somehow find each other again. One question keeps appearing. Who controls all of this? Surely, someone must be in charge. One giant control room. One master computer. One organization making every decision. But the internet has no headquarters, no single switch, no universal controller, no central steering wheel. Instead, millions of independent networks cooperate voluntarily. Each one manages its own infrastructure, its own policies, its own connections. Yet somehow they agree on how to communicate. The internet isn't one network. It's a network of networks. And perhaps that's the most brilliant part of its design.
Imagine two countries building a bridge. The bridge belongs to neither side alone, but both sides benefit from using it. The internet works similarly. Independent networks meet each other at strategic connection points. There, they exchange traffic, not because they're owned by the same company, but because cooperation makes the entire internet faster. Every exchanged packet reduces unnecessary distance. Every direct connection improves efficiency. Competition built the networks. Cooperation connected them. Without both, the internet we know today could never exist. Here's the remarkable truth. The fastest path,
doesn't actually exist. At least, not permanently. The best route, right now, may become the worst route 10 seconds later. Traffic changes. Failures happen. Demand increases. New connections appear. Old connections disappear. The internet never follows a perfect map. It continuously creates a better one. Again, and again, and again. The route your data used yesterday may not be the route it uses today. Yet both journeys can arrive almost instantly.
Nature teaches us that living systems rarely remain still. Rivers change course. Air finds another path. Life adapts. The internet learned the same lesson. Reliability doesn't come from resisting change. It comes from adapting to it. Every rerouted packet, every alternate connection, every recovered failure is proof that flexibility is stronger than rigidity. Perhaps that's why the internet has survived decades of growth without ever standing still. Modern software follows the same philosophy. Applications aren't designed for today's users alone. They're designed to adapt tomorrow. Scalable architecture, reusable components, flexible administration, cloud-ready deployment, reliable APIs. The strongest digital products aren't those that never change. They're the ones designed to evolve. If you'd like to explore professional templates, scalable admin dashboards, application frameworks, and developer resources inspired by modern software architecture, you'll find our curated recommendations in the description below.
Today, we followed your data after DNS answered its first question. We discovered that every journey is guided by countless invisible decisions, not by one machine, not by one company, but by an ecosystem that constantly adapts to keep information moving. And yet, we've only followed the roads. We still haven't explored what those roads are actually made of. Because beneath cities, across deserts, and deep beneath the oceans lies another invisible wonder: highways made of light, the fiber optic cables that carry nearly everything the modern internet has to say. This is NextNet, looking beyond the screen and into the systems that quietly connect the world. Next time, we'll descend beneath the sea to discover why the internet depends on glass more than satellites.